Okay guys, so today's job is to replace this dual channel controller programmer and that thermostat with a Hive. So I'm here to do that. I've already unboxed Hive. Within the box we receive hub, dual channel receiver that's needed because we have a system boiler, an unvented cylinder in here, as well as heating circuit and the Hive thermostat. As you can see, I've got a couple of different proven units, as well as test lamps or voltage detector, whatever you want to call them. So we'll do it correctly as it needs to be done. It's a good one because what we have here is a Salus junction box, dual channel hardwired Honeywell programmer, and also a thermostat. I can't find the other part of this thermostat, but that's not needed anyway, as we're ripping all of this out, replacing it with a Hive. The very first thing I would personally do is make sure everything is in working order before I touch it, because the last thing I want to be kind of held responsible for is it was working before you arrived, now it's not working. So ideally, whenever I go to do a job like this, I make sure that I put heating on, I put hot water on, and make sure that the boiler and the whole system was in working order. So we've got a Variant boiler, as you can see, it's a S-plan, unvented cylinder, not too far from here. So that's what we're working on today. I've already tested that the system is working. Currently, the heating, as you can see, is set to off, and hot water is on auto. Now one of these is hot water, one of these zone valves, and another one is heating. Hot water is off right now, same with heating, because the thermostat, which is just there, is satisfied. So let's just turn heating on. So heating on, depending on where the thermostat is, obviously the other part to that should turn the heating on. Let's just double check. Yep, as you can see, zone valve freely moving now, that's on. And we can also check the demand on the boiler as well. Oh, the water pressure is a bit low, 0.8, 0.9 bar. Ooh, that's a bit naughty. Expansion vessel with an isolation valve. I'm just looking for the filling loop and I found it here. So that's not good. It always does, unfortunately, some of these filling loops. Let's have a quick look. Still 0.8 bar pressure. .9. That's about 1 bar now. Let's just get the light going. I think you can see better now. It's not the boiler screen that's flickering, it's just the lighting on my camera here. But the heat demand is on and the boiler is on now. So what we want to do is we'll turn both heating and hot water off. I'm going to turn the main isolator off, and boiler's gone off as well. Let's close the lid. Next thing, what we want to do is we want to ensure that this installation is safe before we carry out any electrical work. So we need to prove it dead. We need to make sure there's no power running through these cables that we're going to disturb. We've isolated it, but that's not to prove that everything's gone off. Okay, so we just need to be 100% on that. I will also check the fuse size in here as well, but that will come in a bit. So let's have a quick look. So to prove dead, just using a volt stick, a non-contact volt stick, is not enough. By just doing that and then just checking the cable like that is not a way to ensure everything is safe for you to touch. So we need to do a proper test to make sure it's safe before we can carry out any work. So we have a known source and we have two different type of voltage indicators. So these are what we call test lamps, Martindale or Drummond's test lamps. So it's difficult to demonstrate it with one hand. I've got a proven unit there, and all I'm doing is on that proven unit I want to make sure that the item that I'm going to use, or the equipment that I'm going to use, is fit for purpose and it's in working order. Okay, so we tested, we ensured that our test lamps are working. So now we can use these test lamps to go prove dead, which I'll demonstrate how. If you don't want to use your test lamps and you had this type of a unit, it comes in various shapes and various designs. Different manufacturers make them slightly differently, but they all do the same thing. Similarly, this will do the job for us. So as you can see on a tester, it demonstrates that it's working okay. If I can make a good enough contact, come on, tester. Yep, that's better. Perfect. So let's just use these. This makes it slightly easier. So we tested, we just proved to make sure these are working. Technically, because we put them down, something may have gone wrong with them. So just double check it. Okay, now what we want to do is we need to prove dead at the programmer as well as within the junction box, because these are the two places where we will be removing or adding wires into. So that's the first thing I would personally do. So let's have a look. Junction box, I've already removed the screws. And programmer, two screws underneath it, I've already slackened those as well. So we can remove this programmer also. Now the programmer base looks something like this. So we have permanent, earth, neutral and live. That's to energize the programmer itself. Then we have 1, 2, which are blank, 3 and 4. Now 3 and 4 on this programmer, 3 is hot water on and 4 is heating on. Let's double check that on the programmer as well. So as you can see, we have earth, neutral, live. 1 and 2 are not in use, and 3 and 4 is hot water on and 4 being central heating on. So that's these wires here. And what we need to make sure is the main coming here is dead. Okay, so before we touch it, we need to ensure that this is dead. Now there's no harm in testing these as well, but we need to ensure that the main supply coming here is dead, it's not live before we touch it. Similarly, in the junction box, which is just here, the main incoming live, which is this one. So as you can see, the loops on top, it's looped that way and looped this way, which means that doesn't matter which one we check out of these three here, we need to check one at least. Okay, so it doesn't matter which one we do, but that becomes our live point as per colors anyway. And then we have neutral and we have earth. So we need to ensure here as well that we checked to make sure it's all dead before we touch it. Okay, so let's just demonstrate it quickly on the programmer base, because this is where it makes it slightly easier. Now it will be very difficult to do it with one hand. I don't have Ijaz working with me today, so he can't record unfortunately and I test, but let's try anyway. So what we want to do is we want to check between live and neutral. We want to check between live and earth. We want to check between neutral and earth. And we also want to reprove our test lamps, okay? So live and neutral, we're expecting 230 volts. Now on this tester, I've got 50 volts, 120, 230. So here, because it's turned off, we're not expecting anything. Then when we check between live and earth, same again, there should be nothing. If it was switched on, we would have expected 230 volts between live and earth as well. But here we're proving dead, so we're not expecting anything. And then same between neutral and earth, we want to make sure there's no difference in potential there as well. So between live and neutral, I'll just do it this way. So least dangerous conductor, which is neutral first, then live, nothing. Then earth and live, nothing. Then neutral and earth. Let's just separate these slightly so I can get to them. There's nothing there. And then now we need to reprove our unit. Now somebody may say, oh, there's a thumb guard here or finger guard here. Our fingers should be before that or behind it. That's correct. It's just somewhat difficult for me to demonstrate that right now. But ideally, if you can make sure that your fingers are kept behind these finger guards, that's the ideal way of doing it. So let's just try it. Neutral, live, nothing. Earth and live, no light. Earth and neutral, no light. And now we can reprove our unit by just going into our proven unit. Yep, so our tester's still working. So we proved it initially to make sure the tester was working, and then we carried out our test, and now we reproved this tester. Now we're 100% that this connector for the supply that's coming here is dead. We can safely work on it. We will do the same to this junction box as well. It's just slightly more difficult to demonstrate it on here, so I'll do that. But I would have proved my units, prove dead there as well, and then go back to my proven unit to prove my tester is working. I'll try to put my phone just here. I'm not sure whether you can see or not. I hope you can see, and I'm not going to drop my phone. Let's see. Now, I'm not too sure whether you can see or not, but all I'm doing in the background is I'm proving my unit again. I've tested my test lamps. Now what I'm doing is I'm going between neutral and live. There's no light. I'm going between earths and live. There's no light. I'm going between neutral and earth. There's no light. And now I'm going back to reprove my unit to make sure it works. And unit is working, which is perfectly fine. So this whole thing was to do with making sure that we're working safely. Okay, being able to change a programmer and install a Hive base or something like that, all of that's good and well. But we also need to ensure that we do our job safely as possible. So we must ensure that the installation we're working on is dead. Okay. Again, I'll reiterate, just having a non-contact volt stick and just doing like that, or just having a tester in your hand and just going on live, does not demonstrate completely that the installation you're working on is dead and safe for you to work on. Okay, so now we've got that out of the way, what's the next thing? So next is to identify what's happening with the installation, how we're going to wire it up, what all the wires are doing. So the bases here for Hive, we will be requiring live, neutral and earth. to energize the receiver. Now the switches or the demand cables are these here, 3 being hot water and 4 being heating. Hot water we're expecting to go into the junction box, which is brown cable here. From the junction box we're expecting it to go to the cylinder start. From the cylinder start we're expecting it to come back and then get connected to the hot water zone valves brown. Okay, so the hot water we shouldn't have to change anything, which is number 3. However, number 4, which is heating in this setup, because this programmer did not have a built-in thermostat, there's an additional thermostat connected to it, but our Hive has got a built-in thermostat with the system, so we will have to work on this. So number 4, which is heating, which is blue cable here. This cable is currently going up to the junction box here. Let's trace it. So is this cable, this white cable that's running up, going into the junction box, which is just here. And now it's going to be slightly tricky, but it's this cable still. We're looking at the neutral because that's what's connected to number 4, which is hot water demand. So we're looking at neutral, this neutral here going up. This neutral is in connector number 4. Okay, it's in number 4. Let's see what else is connected in number 4. There's nothing at the top, which is fine, but what else is connected in number 4? So it's this brown cable. So if we trace this brown cable, which is this one here, it takes us to this white cable just there. Okay, so this brown is coming and is connected into, well, this is that white cable, which is this one here, this cable. Let's see where this one is going. So this cable is running up to this Salus thermostat receiver. Okay, and then from here is coming back. So as brown went, and it's a 2-core cable, blue cable is coming back. So blue cable then, as you can see, is connected to the brown cable, which is the zone valves brown here, as you can see. So it's this brown connected to this zone valve, as you can see. So this is what creates the demand for the zone valve. So this is the power to the motor of zone valve. This brown cable is connected, and this cable for the zone valve should be going to our heating zone valve here. So what's happening is when we create a demand from the programmer for heating, through blue cable a message goes up. Blue cable is connected to a brown cable. Brown cable then carries that message all the way to this thermostat, depending on whether this thermostat is calling for heat or not. If it is calling, there is a link between brown and blue, and if thermostat isn't calling for heating, that link is broken. But let's assume there is a link there. Thermostat was calling for heating. That brown that brought the message here turned blue, and from blue now is coming back, going back to the junction box, connects to brown. Brown then opens up the zone valve, turns grey, which is a permanently live, to orange, and boiler receives that message. I hope all of that makes sense, but if it doesn't, drop me a line and I will explain it further. Okay, I can open one of those motors up, I can draw it for you, and I will try to make you understand of what all that means. But all we're going to do now is we need to disconnect all of that. One is the power supply, so 230 going to the receiver. Another one is the switch wire cable. So we need to remove both of these cables, and all we need to do is this blue that's coming from the programmer base and is connected to the blue here that was going to the thermostat. We literally just need to switch that blue to the brown of zone valve here. So when we create a message on our Hive base, it doesn't have to consult another thermostat, it just goes directly to the zone valve. That's all we need to do. Okay, looking at the Hive base, let's just look at Hive hub, Hive thermostat, and Hive receiver. Let's have a quick look at the receiver, because this is what we're installing. worktop. It's a dual channel receiver. So we've got same neutral, live, 1, 2, 3, 4. Now, if it is exactly the same as the Honeywell thermostat, then 1, 2 should be unused, 3 and 4, 3 should be hot water and 4 should be heating. But we need to double check that. We just need to make sure that is the case. Now, there is a little diagram on the base itself, as you can see. The base requires permanent, live and neutral. Then 1, which is live, as you can see, so it's connected to live. Number 2 is also connected to live. Number 3 is a switch, and number 4 is a switch, depending on what you're calling. But there is a better diagram that you receive. I believe it's in the thermostat box, which is just here. There is a better diagram, an actual installation guide. It's always best, just to make sure that you don't get it wrong, is to check the installation guides. And that's with everything. I've already opened that up, put a little marker on for you just to find it slightly easier to locate. So here we have 2 receivers, 2B single channel receiver wiring. So that is if we only had heating, or if you were only wiring this up for heating. This is a dual channel receiver, so ignore the first one and let's look at the dual channel receiver there. As you can see, neutral and live, that's permanent, neutral and live. Number 1, which is hot water off, normally closed switch, we're not bothered about that. Number 2 is heating off, normally closed, same again, we're not too bothered about that. Number 3 is hot water on, and number 4 is heating on. Okay, so these are normally open switches. These will only close as and when you create a demand. So this is what we need to use here. So number 3 is hot water and number 4 is heating. This is what we're going to be using, as I said, and this is exactly the same as what we have on the Honeywell base there as well, 3 and 4. So this is what we're going to be using today. So all I'm going to be doing now is, as we made sure that everything is dead, I'm going to remove these cables, I'm going to remove these 2 cables, I'm going to install the back plate, put my earth, neutral and live, permanently live, into the new base, put these 2 in number 3 and number 4, and all I'm going to be doing here is I'm switching this blue that's currently connected and going up to that receiver. I want to put a loop or directly connect that blue to this brown of the zone valve. That's what we need to do. So let me just quickly do that and I'll be with you shortly. Okay, so I've got the base on the wall. As you can see, neutral, live, earth. So this is permanent coming from the junction box. And we have number 3, which is brown, that's hot water on. Number 4, that's blue. I've put a brown tape on it because it is a live cable. But that is your heating demand. What I've also done in the junction box, as you can see, Salus receiver's gone now. So the blue that's coming from the programmer or Hive base as a heating demand is now connected directly to the brown of the zone valve. So I've changed that. So now when there's a demand on that blue, this zone valve activates and tells the boiler to come on. So let's just put this base on. Hang the base. I'm just going to put 1 screw. Okay, so 1 screw nipped up. Let's do the same to the second one as well. Alright, so before I put the cover back on, don't worry, I'm not putting my fingers in there. Let's just turn it on and see what happens. So base is flashing. Boiler's back on, just going through sequence. Both zone valves, one for heating is in off position. Same with hot water is in off position. Let's just put heating zone valve on, shall we? Let's create a demand. I'll pair it up with the thermostat and stuff slightly later. But now that we created heating demand, we're expecting this zone valve to open up, as you can see. So that's opened up, and we're also expecting a demand for heating on the boiler. So there is a demand for heating on the boiler. Let's just leave that in the far open position and let's turn heating off. Sometimes it takes a bit of time to go off, so it's flashing, it's not gone off. But after like 10 seconds or 15 seconds it takes, that'll go off and it should just turn this zone valve off as well. As it's spring loaded, when there's no power coming to it, it just shuts itself. Just still waiting to go off. There you go, it's gone off. I don't know whether you heard the click, and the zone valve's gone off as well. Okay, so receiver is back on now. Currently there's no demand, and all the wiring is all sorted up here as well. This number 7 that you see there, I'm not going to take my fingers to it as it's all live now. Number 7 is the heating demand, and then this loop here, this is for hot water. So let's just create heating demand. Let's just have a quick look at the boiler first to make sure there's no demand on it. So it's just going through purge mode as we've just turned it on, but there's no demand showing, there's no heating demand on it or hot water demand. Both the zone valves are in off position, as you can see. So let's just create heating demand, which should make this point live, which it does. Hot water is still turned off. Let's also create hot water demand. This loop is now on as well, and both the zone valves, both heating, as you can see, is going all the way, so that's in open position now, and same with hot water going all the way, so that's in open position as well. The boiler also has a demand. So all we need to do now is pair up the thermostat. I've already plugged in the hub because it does normally take 10-15 minutes sometimes to power up, to update, and then we need to pair up the receiver and the thermostat too as well. So everything's back to normal, and then we need to demonstrate to customer how to work it. I hope you enjoyed the video.